We're continuing with that same discussion about the wages and pulling out a slip of paper to determine what you make. So after much thought, the teacher has finally decided on permanent employee wages, which are randomly assigned using probability distribution X given below. Additionally, at the end of every year, he gives his employees an hourly wage. The bonuses are assigned randomly according to the probability distribution Y given below. Assume X and Y are independent. So this is our probability distribution. So $9, $12, and $15 are the wages. Then we have the probabilities of each. So we're going to find the mean, variance, and standard deviation. So let's go to our calculator. All right. We're going to go to Stat, go to Edit. And if you want to clear out what's in there, go up to L1. So it's selected, hit Clear. And do the same thing for L2. Make sure you don't delete L1 and L2, but you can clear it. Clear out that list. There we go. And then go Stat, Calc, one variable statistics, but in frequency list, make sure to put L2 in there. Second, number 2 will get you there. All right, and so we have the mean, X bar, and this is dollars. So 1185. They don't have variance on here, but we have standard deviation, 222. When we round. And so to find the variance, remember standard deviation is sigma, and variance is sigma squared. So that means I just take 222 and square it. $493 is my variance. So that's the original wage. Number 2 is going to be the raise. So dollar raise or $3 raise. And they give us the probabilities. So we want to find mean, variance, standard deviation of that also. So go to Stat, Edit. And put those values in. So the mean raise is $1.60. Mean standard deviation is about 92 cents. So then variance, all we have to do is square it. Square the standard deviation. 0.85 when we round it. All right, let N be the new hourly wage for the upcoming year. So we have wages, which is our first table. Then we have, wages. I don't know if I said wages or wages. Wages or raises. There we go. I'm trying to get confused here. So this was our wages. There we go. This is our raises. So we want to find out the new hourly wage. So we are going to add them. So what are all the possible new hourly wages for the new year? So we would take, let's say you make $9, you get a $1 raise. So your new wage, new hourly pay is $10. So we need to do that for all the possible combinations. So let's say you start out at $9, you get the $3 raise. $12. So then we got to move on to, if we start out with 12, get $1, 13, 12 plus 3, $15, and then 15 plus the 1 gives us 16, and then 15 plus 3 gives us 18. So those would be the new pay, new hourly pay. We need to find out the probability of an employee being signed a $9 wage and a $1 raise. So probability of $9 wage and probability of a $1 raise, with a $1 raise. Remember, these are independent, so whenever you do the and probabilities, we can multiply the two probabilities. So we could find this by doing probability of $9 wage times probability of a $1 raise, because they're independent. So we take the probability of $9, which is 0.30, and we multiply it times the probability of the 1, which is 0.70. So 0.21 probability. So this is actually the probability of having $10 as your new wage, right? That's what we just found. Because it was a $9 wage plus a $1 raise, which is $10 as our new value. So we're going to do that for each of the possible wages. So the possible wages are $10, $12, $13, 15 and 16 and 18. Let's find the probability of each of those new wages. We already found $10, so I'm going to write that 0.21. So we're going to do just like part B, where we multiply the two independent probabilities to get the probability of those things happening. So $12, we would multiply 0.45, no, 0.30, because it was, right, the $9 and the $3. So that would be 0.30 times 0.30. So 0.09. So do that for each of these on the table. Go ahead and do that. Okay, check your table with mine. See if we got the same thing. So it looks like $13 has the highest probability. And we're asked for mean, variance, and standard deviation for this table. So let's go to our calculator and do that.
Does it not need to add up to 1?
It should. Did we have to round any? Did yours not add up to 1?
Go ahead.
Okay. So stat, edit, and that's a good way to check too. So put these values in to get our mean and standard deviation. Stat over to calc, 1var statistics. All right, so the mean is 1345. And standard deviation is 240. Okay, y'all agree? All good. All right. But we do need to find variance, so we square. What's 240 squared?
576.
Yeah. Okay, so that was a lot of work. We had to do something to each table. We had to add them. Then we had to find the probability by multiplying. There is a shorter way. So the shorter way is by looking at the mean and standard deviation of each table. And let's see if we can find the pattern. So look at the mean of X, mean of Y. How does that relate to the 1345? Yeah. 1185 plus 160. So that works. So that could have been our shortcut instead of making a brand new table and finding the mean and standard deviation.
It would have saved a lot of time.
Yes, I know. If you watched the Ed Puzzle last night,
I did.
you probably saw this, right? How we just added them. Okay, so then that means that I can write this. Mean of n is really mean of x plus y. It's found by doing mean of x plus mean of y.
And this works for all of them?
As long as they're independent events, it works. But if they're dependent, no. All right, let's look at standard deviation though. Okay, do the standard deviations add up? Can I say this plus this equals that?
No.
No. But can I say the variances added together equals this variance? It's pretty close, right? I think it comes out to be like 580 or something like that. So it's really close. So do y'all remember in the Ed Puzzle what kind of formula we can use?
Pythagorean.
Yep, Pythagorean theorem. So the way this works is variance is found by doing sigma squared. And if I'm doing, let's say this is n, or x plus y, then I would do my variance of x squared, variance of x plus variance of y. And that works. But what I want is standard deviation. So I want to get rid of a squared, so I take the square root. That's where this works. Because you can take the square root of it to find our standard deviation. So our standard deviation of x plus y is found by doing the Pythagorean theorem type formula. So variance plus variance, or standard deviation squared plus standard deviation squared. And this also works for x minus y. You actually use the same formula. We don't subtract, so always positive or always plus. Always positive. All right, so let's summarize, and then you'll do the application problems. So when we add or subtract random variables x and y to get a new probability, new random variable, new situation, then mean is found by adding the mean of x and the mean of y. For subtraction, you subtract mean of x minus mean of y. And then for standard deviation, we do that Pythagorean theorem type formula. Where we do sigma squared plus sigma squared of x and y. Take the square root of that. And with standard deviation, we do not do subtraction. Bless you. We do addition no matter what it says x and y are. We are also going to do add. Always add. So be careful. Don't try to subtract them. You'll add them. No matter what it says here, you're always going to add whenever it comes time to put it in that square root formula. Okay, so then when we do that, we can apply it to some probability models where you find the area under the curve. We use normal distribution. And you will use the new mean and standard deviation and draw the picture. And if you need to, find the z-score. But what we have been doing is we've been using Desmos, where we do normal distribution, normal dist. Or in the calculator, we do norm CDF and inverse norm. So we'll review that tomorrow. So on the application problems, you are going to be looking at this to help you solve the application problems. So I'm going to give you time to work with your partner on that. Let's see how you did. Part A, you do have to find and interpret. So whenever you find, make sure you show your work. So 4.75 times 4.9, 9.65. And then we do have to interpret. So if we select many, many days, the average number of diapers changed per day is about 9.65 diapers. So the stem is like if we select many, many something. So it's talking about days. And then standard deviation, we use that Pythagorean theorem type problem or formula, which is 1.04. And so the number of diaper changes per day typically varies by about 1.04 diapers from the mean of about 9.65 diapers. So that would be our interpretation. And see, you can do it many ways. This is how I did the mean. You can do it each separately and then add it together, or you can do it like I did where I multiplied the mean times the price of each one and added them in the same equation to get 259 per day, which doesn't seem like a lot, but think about it over the course of a month. or a year. It's a lot of money. And then our standard deviation, you would do the same thing. So I did it all in one equation. So the square root of standard deviation times the price squared plus standard deviation times the price squared, which comes out to 28 cents per day as our standard deviation.